Thank you very much for introducing me at this spectacular event. I'm very glad to have the opportunity to present to you today a yet underestimated but very powerful sensor technology. Our credo is to establish new industrial standards with innovative solutions. And in doing so, we have developed a heavy-duty radio frequency identification sensor, which you might also know under the term RFID. So what does it do? In a nutshell, you can measure the temperature or track the ID of different objects in a very extreme environment. One of the main core features of the sensor is its high temperature resistance. For example, on a long-term occurrence, it can withstand temperatures of up to 350 degrees. And on a short-term run, even temperatures of up to 1000 degrees. And furthermore, it withstands dust, acid, moisture, and many more. What else distinguishes our technology from other measurement principles is that it works 100% wirelessly and without any batteries. So imagine, for example, a rotating shaft where you'd like to measure the temperature inside of it on a continuous basis. How would you measure it? Of course, with a wireless temperature sensor. Or, for example, imagine a moving object which you like to track, but which might also get hot sometimes. How would you track it? Of course, with a passive transponder, which is able to track the ID even in a varying setting. So we see our heavy-duty RFID sensor as a core element to the smartification of various industries. In fact, our technology is being used already for smart cooking and smart drive. But as we're here at the Smart Machinery 2021 Forum, I would like to show you some of our reference projects for the smart factory. So in the first example, we use LADLE tracking in the means of batch tracing and process automation. Here, the challenges were the undefined movements of the forklifts and the varying containers' heights and velocities. Furthermore, conventional sensors are often not able to track the ID due to the molten slags and the very hot temperature. Also, optical sensors cannot measure and track the ID when the ladle or the container is dirty. But in this case, together with the company, we could realize process automation and process transparency with our technology. In the second example, we use temperature sensors for thermal processes and coating techniques. In this case, together with a company, we designed our sensors to measure the temperature of a moving object in a hot vacuum chamber. Plasma coating is a very common technique when it comes to improving the surface qualities and properties of various objects. And as you might know, the right chemical bonding is temperature dependent. In the third example, we integrated our sensors inside paper rollers in order to create new business models and shift the after-sales share more toward this direction. So here, the challenges were the high force effects and abrasion effects due to wear and maintenance. So the customer's motivation, in this case, the manufacturer, wanted to digitalize his rollers to increase his after-sales share. So you see, the areas of application for wireless temperature measurement and sophisticated RFID seems to be endless. And here you can catch a short glimpse of our reference partners with which we realized their temperature questions and RFID tasks. Also, if you have a similar question or even a similar challenge, which you do not know yet how to handle it, feel free to contact us anytime afterwards. And always remember, if you cannot measure it, you cannot improve it. Thank you.
Well, thank you very much. I would really love to talk to you a lot more about cooking sensors and smart cooking. Is there a sensor that can make a difference between sugar and salt, a taste sensor or something like that? But that's not what we are going to talk about. It's all about resilience. You are building robust sensors for all kinds of difficult environments. But how does this technology work?
So the technology which we use is called surface acoustic wave. So to keep it short, the reader sends out an audio wave or radio signal to the sensor, which is turned into a surface acoustic wave. In the next step, this surface acoustic wave is sort of modified by the resonance frequency. So imagine the resonance frequency changes with the temperature, and this change in temperature can be read out by the reader software. And all of this happens in just a fraction of a second and without any cables and completely wireless and without batteries.
So the environments that those sensors are used, they are very different. They're hot, they're cold, they're dirty, everything under the sun. How do you ensure that they work in every condition except from the heat and the cold?
So right from the beginning, we paid much attention to keep everything very modular. So whilst the core principles and the core components always stay the same, the housing and the sensor design can vary pretty much according to the customer's specific needs and demands. And over the past couple of years, we've gathered lots of application know-how. So if you have any similar questions or challenge, feel free to ask us afterwards. Thank you.
Well, thank you very much. Thank you for your talk.